Okay. So the task here that I've given you is to fill in this table. Now, I debated about whether to write the y equals f of x part. Okay? Could have just written x squared and eliminated any confusion that would be, but I wanted to see what you'd do with it. And many of you did something very nicely with it, okay? And we'll do that, but right now I'm just going to concentrate on the x squared. And then I'll show you how to write it out with the f of x idea. That's not multiplication. Don't multiply f times anything. But we'll deal with that, and your assignments will deal with that. Okay, anyhow, then for -1, okay, for -2, you get -2 squared. Now, the whole quantity is squared. If you write -2 squared without parentheses around the -2, then your answer would be -4. Because you wouldn't be squaring -2, you'd be squaring 2 and then applying the negative. So you want to have the parentheses around that. Okay? Okay, now, I did recommend that you work from the bottom up, so you don't have to worry about the negative signs and these little technicalities. So if we start down here in the order that I recommended, you square 2. I don't really need parentheses around the 2, so I'm not going to, on this one, I'm not going to bother with the parentheses. We do need them for the negatives. I didn't see many right answers on 1/2 squared, which, as I said, is consistent with the idea that people can't do fractions. It's because of deficiencies in our schools and because of overuse of the calculator. Now, fractions are very important because in pre-calculus you're going to have to do fractions with variables and polynomials and numerators and denominators. So we got to be sure we really understand this. So 1/2 squared is, of course, 1/2 times 1/2. Now, what's the rule for multiplying fractions? Well, you might confuse that with the rule for adding or subtracting fractions. Okay? Now, we've got to get that right. You know, we've got to make sure we understand these rules from near the beginning. Anyhow, 1/2 squared is 1/2 times 1/2. The rule for multiplying fractions is you multiply the numerators and you multiply the denominators. Unlike what you do if you're trying to add or subtract, in which case you need a common denominator. Well, that gives you 1/4. And the rest is straightforward. And I'll write that one out this way. Negative times a negative gives you the positive, so you just get rid of the negative signs, you get 1/2 times 1/2. Multiply the numerators and denominators, you get 1/4. Okay? Now this function notation. Writing this calculation out with function notation. Y equals f of -2. Okay? Now, f of x equals x squared. So, if I write f of -2, I've replaced this x with -2. I'm substituting -2 for x. Make sense? Well, if I substitute -2 for x, I've got to substitute it everywhere in this expression. This is very important. So we have this. Okay? Can you see the board? Okay. It's not always the best place to sit, but it's the most comfortable chair. So I'm totally with you as long as you can see the board. And if you really want to move to a better position, you take that chair with you. Okay. Okay, very good. Make sense? That's it. That's function notation. Okay? And many of you wrote that out. It wasn't necessary, as I said, you could concentrate on the x squared, but most of the people who wrote it out did a pretty good job of it. So that equals the dot, dot, dot means, yeah, you probably want to write it -2 times -2 equals 4, but since I already did that, I'm not going to repeat it here. Okay? So function notation is very simple. Now some of the things we do with it and why we do it, well, let's just learn to do it, right? I think that assignment is due like Thursday. My open math, you will find that most of the problems are accompanied by videos that explain how to do this type of problem. Okay? So that's going to get your feet wet. Even if all you do is imitate, get the right answer, that's going to give you a head start when Mr. Gallagher or I start talking about these things, assuming that you know it. Okay? Because when we go to pre-calculus class, but a little more than half of you are going to follow me into that class, I'm not going to explain all this in detail. Okay? I might give you a brief explanation because I've assumed that okay, it might have been a little while since you had the course and need a quick refresher. But you're going to need to understand this. Okay, well, now I can make a graph. Okay? And we're running short of time and I need to show you these graphs. Okay, so I've got these points. So I can draw a graph. And when you're doing this by hand, slop it down. Don't be too meticulous. Okay? Now, if you really want to, your pride can't help trying to make the thing look really beautiful. Well, I certainly respect that. It's a good habit. But you have time constraints too, so balance things. When I say slop it down, don't try to make it sloppy, but do it quickly. Or after a little practice, do it quickly. So here's x, here's y. Your x values go from -2 to 2. Okay? Now, you got to position -1 and 1, and -1/2 and 1/2. And that's pretty easy to do. You just put -1 halfway between -2 and 0. That's where it goes, right?
If they're out or not.
And you put 1 halfway between 0 and 2. And hopefully your distance from 0 to 2 is the same as your distance from -2 to 0. But I've got a bad angle on the board and I'm careless, so this is a little more compressed than this is, but it's going to be okay, so we're going to see the shape of the graph. Okay, but try to do that somewhat accurately. Get -2 and 2 at equal distances, and then just divide the interval here in half to get this. You can eyeball the halfway point. You don't have to measure with a micrometer. Okay? And same thing here. So there's 1 and -1, and then you cut the interval from negative 1 to 0 in half to get negative 1/2. And here's 1/2. Okay? Now, what you don't want to do, well, if I can put that chalk out of there, I can show you. Okay. What's wrong with this picture? Again? Yeah. The intervals are not consistent. Okay? From 1/2, negative 1/2 to 0, on this picture, is the same distance from negative 2 to 1, negative 1. Okay? It's not going to work. You're not going to get the right shape of the graph. So you got to be careful how you lay out the graph and make sure that one unit here is the same as one unit somewhere else on the x-axis. Okay, well then we can quickly go from 4 to 2 to 1 to 1/2. I'm not going to label that because it's going to get in the way. There's 1/2 and there's 1/4. Okay, from 2 down to 1, well, we subdivide the interval from 0 to 2. And then from 0 to 1, you divide that in half and then you get this. And then from 0 to 1/2, 1/4 is half of that. Okay? So right there, we've got all the numbers we need. But of course, you might want to have 3 in there, so just halfway between 2 and 4. And this should all be clear and obvious. If it's not, give it some good thought. If you've got questions, email me. I'm asking. Okay? Because I monitor this stuff. So, now we get the points on the graph. Here's negative 2, 4. We're not going to label them all because we're running short on time. Negative 1, 1. Negative 1/2, 1/4. And of course, good old 0, 0. And then 1, 1/4, 2, 1, 1/2, 1/4, 1, 1, and 2, 4. So there's the graph that corresponds to this function. At least on the domain from negative 2 to 2. Now, the domain is the set negative 2, negative 1/2, negative 1, 0, 1/2, 1, 2. The domain is a set of points, set of the x values that are represented on your graph. Okay? Now, there's another way to write this domain. Well, there's another function. It's got the same formula, but it's got a different domain. If I sketch a smooth curve here in green, then this is a different function. The domain of this function okay, so the domain of the function in blue, I should have written that in blue. I'll circle it in blue. The domain of the blue function is just these 7 points. The domain of the green function is the closed interval from negative 2 to 2, meaning all the x values between negative 2 and 2, because this is a continuous curve. So for every value between x value between -2 and 2, we have a y value. Okay? The range is a set of y values. Now you're going to see that. I won't have time to do that. Okay? This is one of 5 basic functions. We don't have time to do the other basic functions. And my open math, well, my open math does address these functions. Okay. So, okay, this is the squaring function. You see it? Okay, y equals f of x equals x cubed. What do you call that? Well, that's a cubing function. Y equals 2 to the x. Okay, the word basic is important. Basic cubing function. This is a basic exponential function. I'll abbreviate the word function because we're officially out of time. We've only got 2 more to write here. Y equals 1 over x is your basic reciprocal. Function. Here's your basic reciprocal. I don't get the word in here. Well, there's more to be said. I'm going to add that to a short video because we're out of time. I'll do that video a little bit later and post it.